Welcome to the deep dive. We're here to basically take a whole load of information, find the really important bits, and, give you that shortcut to being genuinely well-informed.
That's the goal.
And today we are diving deep, really deep into the world of generative AI. It's fascinating and moving incredibly fast.
It really is. And it's not just AI predicting things anymore, is it?
No, exactly. It's AI actually, creating completely new content.
Yeah, brand new stuff.
Our source for this dive is Amit Bahree's book, Generative AI in Action. Really practical stuff in there for anyone interested in, building what's next in software.
It's a great resource, very hands-on.
So our mission today is to unpack generative AI for you. We want to look at what makes it tick, its building blocks.
See what it can actually do.
Right, and explore the really crucial things to think about when using it in the real world, especially if you're curious about new tech and its impact.
And there are some genuinely surprising things in here, some real aha moments, I think.
Definitely. So let's get started. Generative AI, it feels like such a huge shift.
It is, fundamentally. For ages, traditional AI was mostly about prediction or classification.
Like figuring out what something is or what might happen next.
Exactly, based on data that already exists. But generative AI, it completely flips that. It creates novel, totally original content, stuff that just wasn't there before.
Like you said, images, text.
Music, even code, 3D models. It's a creative engine, really. It has totally changed the game.
And speaking of changing the game, the speed of adoption is just, wow. We have to talk about ChatGPT.
Oh, absolutely. The numbers are staggering.
100 million users in 2 months.
Yeah, just 2 months. It's the fastest tech adoption, ever in human history.
It just shows the massive curiosity and, frankly, the excitement around this.
It really does. And it connects to that bigger picture, how quickly AI capabilities have, in some areas, just blown past human parity. Things like image recognition, language understanding.
It's not science fiction anymore.
No, it's right now. It's shaping industries, our daily lives, as we speak.
Okay, so if generative AI is this creative powerhouse, what's driving it? We hear large language models, LLMs, all the time. For someone maybe familiar with basic AI, how is an LLM different? What's the magic there?
Good question. LLMs are basically the backbone for a lot of these generative apps. Think of them as being trained on just unbelievable amounts of text data.
Billions of words.
Billions, maybe more. Documents, websites, books, everything. And they learn the patterns, the structure of human language from all that. The magic, as you put it, is their ability to predict what comes next.
Like predicting the next word in a sentence.
Pretty much, yeah. Or the next token, technically.
Yeah.
And by doing that over and over, they build up responses that are coherent, relevant, and often sound remarkably human.
And who are the big players we should know about?
Well, OpenAI is obviously huge with their GPT models.
Yep.
GPT-4o is the latest, and it's multimodal, meaning it handles more than just text.
Images, audio.
Exactly. Then you've got Meta's Llama 3, which is interesting because it's open source. And Anthropic has their Claude 3, Family, Haiku, Sonnet, Opus, different models for different needs.
So if these LLMs work by predicting the next word, how do we tell them what we want? That's prompt engineering, right?
Yeah.
The art and science of giving instructions.
Precisely. Prompt engineering is like learning how to talk to the LLM effectively, giving it really clear directions. And a good prompt isn't usually just a simple question.
What goes into it then?
Usually several things. Clear instructions, obviously. The main content you want it to work with. Sometimes you give it input and output examples like, here's what I mean, give it back to me in this format.
Ah, okay. Examples help.
Definitely. You might add cues to guide its tone or reasoning, and sometimes supporting content for more complex tasks.
Yeah.
But here's a surprising thing, especially with models like GPT.
Yeah.
The order you put that information in the prompt, it can really matter. It can significantly change the output.
Huh. So it's not just what you ask, but how you structure the ask. Interesting. And speaking of how they process things, let's talk tokens. The book calls them the new currency. What's a token, exactly?
Right. Tokens are key. Think of them as the basic building block of text for the LLM. It could be a whole word or just part of a word or even punctuation.
Okay.
For English, a decent rule of thumb is maybe one token is about 4 characters, or like 0.75 words, 3/4 of a word.
Can you give an example?
Sure. Like the sentence, I have a white dog named Champ, that might break down into, say, 8 tokens. I have a white dog named Chi Amp, something like that.
Okay, I see.
And the crucial insight, the new currency idea, is that every token you send to the model And every token it generates for you costs something. It costs money, it costs processing time.
Ah, so language becomes like a budget item.
Exactly.
That
Developers have to manage that budget. More tokens mean higher costs and usually slower performance.
Got it. Which leads right into the context window. That's the limit on how many tokens it can handle at once.
Precisely. It's the maximum number of tokens the LLM can process in one go, in a single pass. And some of the sizes now are just staggering.
Like what?
Well, GPT-4o can handle, I think, 128,000 tokens. And Google's Gemini 1.5 Pro, they're talking about 1 million tokens.
1 million! Wow. But there's a catch, right?
There's always a catch.
Yeah.
Computational cost, the processing power needed, it scales quadratically with the context window size.
Quadratic, meaning
No.
much, much more expensive.
Much more expensive and much slower. So yeah, 1 million tokens lets it remember a huge amount, like a whole book, but it comes with a significant performance hit, much higher latency. It's a trade-off.
Makes sense. Great for analyzing a big document offline, maybe not so great for a snappy chatbot.
Exactly that. You have
Yeah.
to choose the right tool, the right setting for the job.
Okay. So how do we control the output? Sometimes you want facts. Other times you want, I don't know, a poem. How do you dial up or down the creativity?
Yeah, that's where parameters come in. The main ones are usually called temperature and top. Think of them like creativity dials. Temperature controls randomness. Lower temperature, closer to 0, makes the output more predictable, more deterministic, good for factual stuff.
And higher.
Higher temperature lets it take more risks, be more creative, maybe even a bit wild. Top is similar. It works with probabilities of the next token. You generally fiddle with one or the other, not both at the same time.
Got it. Now, here's something that really jumped out at me from the book, this idea of emergent behavior. What is that? It sounds almost spooky.
It's not spooky, but it's fascinating. Emergent behaviors are abilities that these LLMs show. Abilities you just couldn't have predicted by looking at smaller versions of the models.
They just appear
Yeah.
as the models get bigger.
Pretty much, yeah. Capabilities that seem to emerge out of the complexity. The book has this great example.
Tell me.
An LLM was given a really complex C function, like using pointers, bitwise XOR operators, tricky stuff. And it was asked to convert to Python, and it did it. But the amazing part, it didn't just translate it line by line. It actually figured out the underlying logic, a sophisticated two-pointer technique without any explicit hints in the prompt.
Whoa. So it understood the concept behind the code.
It certainly seems that way.
Yeah.
It showed a level of comprehension way beyond just matching patterns. It's genuinely unexpected, emergent understanding.
That is mind-blowing. Okay, so LLMs are incredible with text, but generative AI isn't just text, right? Images are everywhere.
Absolutely. Generating images from text descriptions is a huge application. And we're not talking about Google image search finding existing pictures.
No, this is creating something totally new.
Totally new. You could ask for, I don't know, a squirrel riding a tiny bicycle on the moon, and it will generate that image, something that's never existed before.
And the popular tools here are things like DALL-E 3.
Yep. OpenAI's DALL-E 3 is a big one.
Yeah.
And Stability AI's Stable Diffusion is another major player, widely used.
How does that even work? Technically, what's the leap?
Well, there are a few core architectures. You have things called variational autoencoders, VAEs, which are good for certain tasks like fixing images or changing styles.
Okay.
But the real revolution for generating those really high-quality, diverse images came from diffusion models.
Diffusion. How does that work?
In simple terms, they start with pure random noise, just static, and they learn, step by step, how to reverse that noise process, gradually refining the static into a coherent image based on the text prompt.
Ah, like sculpting from noise.
Kind of, yeah. And they're really good at avoiding mode collapse. That's where older models would just keep generating slight variations of the same few things. Diffusion models give you that incredible variety.
So any tips from the book on getting good images? How do you prompt an image generator effectively?
The main advice is be descriptive. Really descriptive. Don't just say car. Say a vintage red convertible sports car driving along a coastal highway at sunset, dramatic lighting.
Specificity matters.
Hugely. Also, think about the mood, the style, the artistic feel you want. And it's worth knowing the current limits.
Like what?
Well, things like generating perfectly realistic human hands can still be tricky sometimes, though it's getting better fast. Same for faces occasionally. And if you want specific text or a logo in the image, it's often better to generate the image first and then add the text manually in an editor. The models aren't really designed for perfect text rendering within the image itself.
Good practical tips. Okay, beyond images. Code generation, you mentioned that. It sounds like it's becoming a kind of AI pair programmer.
That's a perfect way to put it. Tools like GitHub Copilot, which are trained on literally billions of lines of code, are massively boosting developer productivity.
How much?
GitHub's own data suggests something like 96% of developers are faster on repetitive coding tasks when using Copilot, and 88% just feel more productive overall. It's a big deal.
Wow, and it's more than just suggesting the next word, like in text.
Oh yeah, much more. These tools look at the bigger picture. They see other files you have open, understand the design patterns you're using, even your coding style within that project.
So it considers the whole context of the software.
Exactly. It goes way beyond just the line you're currently typing. The suggestions are much more relevant and, frankly, helpful because of that context.
Okay, let's pivot slightly. This is super important for practical use. Making the AI smarter with your specific data. LLMs are trained on public stuff, right? They don't know my company's internal document.
Correct. That's a major limitation. Their knowledge is frozen at the time of their last training, and they don't have access to private, proprietary, or real-time information.
So how do we fix that? That's where RE comes in, retrieval augmented generation.
Exactly. RAG is often called the secret weapon for enterprise AI. It's designed precisely to solve that problem. The core idea is data grounding.
Data grounding.
Yeah, connecting the LLM to external specific data sources relevant to your task. It's like giving the LLM a library card to your company's library or access to real-time data feeds.
So it can look things up.
Essentially, yes.
Yeah.
It makes the LLM's answers much more accurate, reliable, and up-to-date because it's not just relying on its internal, potentially outdated generic knowledge.
How does RAG actually work then? What are the pieces?
It's basically a two-step process. First, there's the retriever. When you ask a question, the retriever searches your external knowledge base, could be internal documents, databases, whatever.
Finds the relevant info.
Finds the most relevant snippets of information. Then, second step, the generator, which is the LLM itself, takes your original question and the information retrieved by the retriever.
And puts them together.
And uses that retrieved information to construct a much better, more grounded, more factually accurate answer.
Okay, that makes sense. And the book really emphasizes the role of vector databases and vector search here. Why are they so critical for RAG?
They're the engine that makes the retrieval part fast and smart, especially at scale. See, vector databases, things like Redis, Azure AI Search, Pinecone, they don't store text as just words.
You know how they store it?
They store it as numerical representations called embeddings. These are basically long lists of numbers, vectors, that capture the meaning, the semantic essence of the text.
So words with similar meanings are close together.
Exactly. Puppy and dog would have vectors that are numerically close in this high-dimensional space. When you ask a question, your question also gets turned into a vector.
And it looks for the closest matches.
Precisely. It finds the text chunks in your database whose vectors are closest to your question's vector, usually using something like cosine similarity, which is what OpenAI's models use. It finds relevance based on meaning, not just keywords. That's the power.
Which brings up a practical problem, the chunking challenge. You can't just dump a 500-page PDF into the system, right? Because of that context window limit we talked about.
Exactly right. That context window is a hard limit.
Yeah.
So if you have large documents, you have to break them down into smaller, manageable chunks of text before you can create embeddings and put them in the vector database.
How do you decide how to chop them up?
Well, there are different strategies. You could just do fixed length chunks, say every 500 words, or a sliding window, which overlaps the chunks a bit to keep context.
Okay.
Or more sophisticated methods try to chunk based on punctuation, paragraphs, or sections, trying to keep semantically related sentences together. How you chunk can actually have a big impact on how well the retrieval part works.
Right, makes sense. Okay, zooming out again. Building and running these things in a business setting, an enterprise. The book talks about Software 2.0 and the era of copilots. What's that shift about?
Software 2.0 is this idea that we're moving from writing explicit code for everything to building systems where algorithms learn from data. AI isn't just an add-on, it becomes a core part of the system's logic.
And copilots.
Copilots are the manifestation of that, like the coding example. They're AI assistants deeply integrated into workflows, boosting human productivity, making how we interact with software more, well, conversational and powerful.
So if you're building one of these Gen AI apps, what does the stack look like? What are the main layers?
Broadly speaking, you've got a few key layers. At the top, there's usually an orchestration layer. This manages the overall flow, complex tasks, handling prompts, chaining calls, Frameworks like semantic kernel, LangChain, or LamIndents live here.
Okay, manages the workflow.
Yep. Then you have the grounding layer. That's where RG happens, data
Got it.
ingestion, creating embeddings, the vector database, retrieving information.
Makes sense.
And finally, a really crucial layer is response filtering. This is about quality control, content moderation, applying responsible AI rules, maybe caching results for speed and cost savings.
Okay, speaking of cost, that seems like a huge operational thing to manage.
Oh, it absolutely is. And easy to underestimate. Remember, tokens cost money. Every API call adds up. So optimizing those calls, maybe using smaller models for simpler tasks, and especially using caching. It's
You should have
vital.
caching, like saving answers to common questions.
Exactly. If the system gets the same or a very similar prompt again, it can just return the saved response instead of hitting the expensive LLM again.
Yeah.
The book had a great example of this. In one case study, implementing LLM caching resulted in a 69.37% time saved on responses. That's huge, faster for the user, and way cheaper to run.
Nearly 70%. Wow. Okay, cost is one thing. What about security? These models seem powerful, potentially risky.
Hugely important. There are significant risks. Prompt injection is a big one. That's where someone crafts a malicious input to trick the LLM or bypass its safety filters.
Oh.
They might hide commands using base64 encoding, for instance. Or imagine a prompt that interacts with a database. A clever input could potentially perform a SQL injection attack and maybe delete data.
Yikes. What else?
There's model denial of service, overwhelming the model with complex requests. Data poisoning, corrupting the training data to make the model unreliable or biased. Over-reliance by users on potentially flawed outputs. Even model theft, trying to steal the model's weights.
So how do companies defend against all that?
It has to be layers of defense. Strong access controls, definitely. Rigorous validation of any input coming from users. Regular security audits. Being careful about third-party tools you integrate. Securing the AI service configurations themselves. Proactive threat modeling. It's a constant vigilance thing.
Which ties into responsible AI, RAI. It's more than just making sure it works, right?
That's right.
Hallucinations are a big topic here. Why do LLMs just make stuff up?
Yeah, hallucinations are a fundamental challenge right now. It happens because LLMs are optimized to generate plausible, coherent text based on patterns in their training data. They aren't built to verify facts in the way a human would.
They don't know it's true.
They don't understand truth in our sense. They're incredibly sophisticated pattern matchers. If a plausible-sounding falsehood fits the pattern, they might generate it. We can't completely eliminate hallucinations today. That's a major research area.
But we can reduce them.
Definitely. Using high-quality, less biased training data helps. Crafting very precise prompts with clear context is key. And crucially, grounding the LLM with RAG, giving it access to verified external facts that significantly minimizes the tendency to hallucinate.
And to find these kinds of problems proactively, companies use red teaming. What's that?
Red teaming is essentially ethical hacking for AI. You have an independent team whose job is to try and break the AI to find vulnerabilities before bad actors do.
What kind of things do they try?
All sorts. They might probe for unexpected power-seeking goals. They'll try to jailbreak it, trick it into bypassing its safety rules about generating harmful content. They'll test rigorously for biases, like asking it to describe leaders and seeing if it shows gender or racial bias.
Trying to anticipate misuse.
Yeah, exactly. Find the weaknesses and fix them before they get exploited.
Are there tools to help automate some of this safety checking?
Yes, there are. Services like Azure Content Safety, for example, can automatically scan text for harmful categories, hate speech, sexual content, violence, self-harm. It also has tools to detect if prompts are trying to jailbreak the model or check if the output is grounded in the provided sources.
And Google.
Google has the Perspective API, which is often used to score the toxicity of online comments, helping filter abuse. These tools are becoming essential for deploying AI responsibly.
Okay, last big area, evaluation. How do you even measure if an LLM is any good? It seems so complex.
It is incredibly complex and crucial for production. You can't just rely on simple metrics like how many words overlap with a reference answer. Qualitative assessment is vital.
Meaning humans have to look at it.
Often, yes. Especially for subjective things like creativity or nuanced tasks like summarization. Humans need to evaluate fluency, coherence, factual accuracy, potential biases, things automated metrics often miss.
But that sounds slow and expensive. Are there better benchmarks emerging?
There are. The field is developing much more sophisticated benchmarks. Stanford's holistic evaluation of language models is a big one, trying to be comprehensive.
Okay.
There's AIM, specifically for evaluating text-to-image models. MMLU, massive multitask language, Understanding tests knowledge across tons of subjects, from basic stuff up to professional level.
Pushing the limits.
Right. And MMMU pushes even further into multimodal tasks, using images to test perception and reasoning. There's even one called MoCA that tries to evaluate how well the LLM aligns with human moral judgments.
Moral judgments. Wow, okay. And the book mentioned GEVAL, using an LLM to evaluate another LLM. How does that work?
Yeah, GEVAL is a really clever idea for scaling evaluation. You use a powerful LLM, like GPT-4 as the evaluator. You give it the output from another model, say a summary, and a set of criteria like relevance, coherence, consistency, fluency.
And the AI scores it.
Exactly.
Yeah.
The AI evaluator scores the other AI's output based on those criteria. It's not perfect, but it's a way to get large-scale, reasonably good qualitative feedback much faster than relying solely on human reviewers.
Fascinating. Well, we've covered a ton of ground here, from the basics of generative AI, what LLMs are, tokens, context windows.
To what they can create text, images, code, and how things like RAGI make them smarter with specific data.
Right. And then all the crucial enterprise stuff. The stack, cost, security, responsible AI, evaluation. You should definitely have a much clearer picture now of how this tech works and why it's changing software so fundamentally.
It really is a paradigm shift, which leads to a thought, maybe. As these LLMs keep learning, keep getting bigger and more capable, what totally unforeseen emergent behaviors might pop up next?
Yeah, things we can't even predict right now.
How will that change our understanding of what AI can actually do, or what intelligence even means? It's something to ponder.
Definitely food for thought. Look, the journey with generative AI is really just starting for everyone. Things are moving incredibly fast. It's worth keeping an eye on developments, especially around responsible AI and evaluation.
Those areas will be key to shaping how this technology evolves and integrates into our lives.
Absolutely. A fascinating deep dive today.